Hello, everyone. I am VB. I do everything that needs doing at Hugging Face. Not sure if you've heard of Hugging Face. Who knows what Hugging Face is? Nice. I love building stuff with local LLMs. And what I do at Hugging Face is essentially build glue work tools and scripts that help make these tools work better together. What is this talk about? This talk is about on-device LLMs, on-device machine learning, and what you can do with it, what is possible with it, and more specifically, what does the process of sort of creating these models look like, and in the end, what are some things which may go wrong, and what are the things that Hugging Face and I are quite excited about when it comes to the landscape. All right. Quick disclosure, I prepared for this talk to be 45 minutes long, and I just got to know that it was 30 minutes long. So bear with me. I'm going to do some live coding stuff, and hopefully things would break, and we'd have some fun. Cool. So how many of you have run a LLM on device? All right. How many of you used llama before? OK. How many of you have used llama.cpp before? Nice. OK, brilliant. So just to prime everyone, what we're going to do is we're going to try to sort of run an LLM on browser. OK? And the hope is that if everything goes well, then we'd essentially give an issue to the LLM, and we'd ask the LLM to create a structured JSON out of it. Right? So we'll say that, hey, I'm having issues with, I don't know, the login page. And this is unstructured data, with random things. And then we define a JSON schema on the left, which essentially is what's the title of the issue, what's the description of the issue, what's the priority, and so on. And we hope that the LLM does its thing, and we get a structured output in the end. Quick caveat, the LLM in question over here is running just on my browser, right? So we load the LLM on the browser, and then we ask it to do its LLM things, right? Cool. So as you can see over here, oh, that was fast. I was hoping it was slow. Anyway, so what happened here is over here, it took this text, right? And the text over here is the login page is not properly handling password reset requests, blah, 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 blah. So it creates a title, which is error, password reset request not being resolved. It gives a description. It gives a label, bug, security, whatever, priority high, estimated time, 1 week, and so on. Just to prove that this actually works on my device, here's some quick stats. What you want to look at is this memory usage and GPU usage. So hopefully when I click on generate structured issue, you would see a spike in the yellow bar, which means that it is actually using the GPU compute on my laptop. Fuck. Oh, my God. OK, wait. Thank you very much. OK, let's see. Hopefully it works now. And oh, come on. Actually, woohoo! So again, everything essentially works on the device, and this is where the LLM just messed up big time. It's estimated time, 1 full stack trace tracing, identified, blah, 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 blah. Well, hello, my sweet child. But well, it's a great demonstration of what you can do with just a tiny 1.7B model. This is what, a gigabyte in terms of your RAM usage. And it takes unstructured data, fits it into a JSON schema, and gives us a nice issue preview, and so on. So this is actually already possible now, running on your sort of Chrome browser. This also means that you don't need to deploy an LLM. You can just offload all the compute at the edge, right, itself. Cool. Let's go back to the boring stuff. Please work. Of course. Amazing. OK, it worked. So how does one run stuff like this? There's like a plethora of like tools, apps, frameworks, libraries, and so on. Um, the first one being llama.cpp. This is like the bread and butter of on-device machine learning. You have ollama based on it, llama-file, LM Studio, like pretty much anyone who does like on-device sort of machine learning uses like some form of llama.cpp embedded. Then there is MLX, which is more specific to the Apple ecosystem. There's like MLX LM, there is MLX VLM. There's, again, LM Studio supports it, local chat supports it, and so on. So just for context, these are ways that you can run these models on device, right? Then there is Onyx runtime. This is brilliant, sort of both runtime as well as like downstream libraries from Microsoft. Then there's TVM, which has been around for a while, and they have like web GPU support and so on. So the demo that you saw before was from WebLLM, from like TVM folks, and like the whole demo was powered by web GPU. Then there's Whisper.cpp, and the whole plethora of like VLLM, TGI, SGLang, the libraries that you would use for on-device or just on your like CUDA-based runtimes. Cool. But then, what else can you do with this on-device thinking? Let's try to do like a quick demo with like everyone, since everyone has been talking about like model context protocol and like using these using like different sort of disparate tools, functions, and sort of different servers together. Let's see like what we can do with like local models, model context protocol, and so on. This is where comes like a really small library that we recently released. It's called Tiny Agent. What it does is as it says, it's like a less than 100 lines of code. It's a library which allows you to connect different tools to LLMs, and you can just run it with, like we have a TypeScript client called Tiny Agents. We also have a Python client, Tiny Agents, and you can just create very simple workflows and use local models, deployed models, OpenAI, Claude, whatever fancies you with this. So let's try this. OK. So as always, like you can see the GPU usage here. And what I'm going to do is I'm going to deploy like a very quick LLM server using llama.cpp on my Mac. This uses like Qwen 330B parameter model. Hopefully it would load. And when it loads, you would see like that the memory usage sort of spikes up. Load faster. Maybe not. Take your time, it's fine. Perfect. So you can see that the model is now deployed, and like it uses like some amount of memory. I am cheating a bit because like this is the full spec'd out Mac. It has like 128 gigs of RAM, but you can do this with like a 8B model, 4B model, 2B model, and so on as well. Cool. Let's try and do some fun stuff now. So to get things started, let's try and see if I can use a Hugging Face space. Let me open a new tab. So a space can be oh, I opened the model. Well, I can go here. So let's say there is this space which creates images based on text, right? So I can say Dogo Ghibli. Hopefully, at some point, it would run and give me some sort of output. Hey, it works. Now let's see if we can, without telling the model explicitly, to use this. Let's see if the model can figure out to use this space just from my CLI, right? And hopefully create something. Cool. Let's go here. So I created like a quick workflow for this with Tiny Agents. what it does is, this is local image gen. So I created like a very quick prompt, and I say, you are an agent, do whatever the hell the user tells you, and like in the end, just say that, help the user create high quality images and so on, right? And then I define like an agent.json, and I give it my local endpoint, which is, whatever, 8080, and then I pass it the URL of the space, which is an MCP server in this case, and nothing else. So I just give it I just give the MCP URL of the space itself, and then let's see, how do I run this? Wait. Okay, so then I do like npx, Hugging Face tiny agents, run local image gen. Again, you can do this with the Python client as well. I just didn't have the time to set up like a virtual env and so on, but it's literally the same experience. So as you can see that the agent is now loaded with one tool, which is the Flux Schnell in this case. And so let me see. Of Labrador, Ghibli style, and I'm just going to give it, like, I'm just going to throw it off itself and say, make it 1024 x 1024 in dimension. Now, hopefully, if the demo gods are with me, we will see some fun. So you can see that the model is thinking now. You can see that the user wants to create an image and so on. This is the model sort of like thinking, like figuring out which tools it can use. Then over here, it figured out that the prompt should be a Labrador in Ghibli style. The dimensions are this thing. So the width and height of both are both like 1024. This is all like a local model, like, doing its thing. And it thinks a lot. And over here, it's making the tool call. This is where the chances of it messing up are the highest. So now we wait. Maybe it works. OK, so over here, you can see that it did a tool call, and it returned like an image URL. Let's see how this image looks like. Oh, so we have a dog, like we have a nice sort of image of a dog, Ghibli style. It is cute. OK, so this is something which is like already like working, and you can see that my code actually just terminated with an error, but it's fine, doesn't matter. Let's try and do like something else. Let's try and ask it. Actually, let me see if the server is still on. Is it? Is it not? Maybe? No? Let's turn it on again, and now let's try to do like a local search. So npx. So now I want to ask it to search like huggingface.co and give me like maybe like the list of top 10 models. Let's try and see. Let's ask it to what? My R stopped working. No, it works now. Okay. So let's say that I have a search agent. So I give it access to my computer via like Playwright, which is another MCP server. Again, the model URL, I give it like a local model path. I give it a prompt, and this time I change the prompt to like follow the instructions given by user, think which tools you can use, whatever. Cool. Let's go here. Let's do again. And run search agent. Cool. So now you can see that it has loaded like 25 tools. It's like browser close, browser open, install, all of that good stuff. And hopefully now it would know how to open a browser, right? So let's give a very simple prompt: find top 10 models on Hugging Face. Hopefully, it should be able to open a browser. Let's see. Okay, so it's like you can see that it's thinking. Go to this browser. It automatically opened the huggingface.co/models. It opened the Chrome browser in this case. And let's see where it is now. So you can see that it essentially it did browser navigate. Then it went to this page. It got the HTML of it. That's the URL. That's the page. It got all the information about it. And that's a lot of information about it. And then you keep scrolling, keep scrolling, keep scrolling. And it's still thinking, because why not? Hopefully it would work soon. OK, this is great because it errored out. I don't know what else to do right now, but anyway, so essentially you can see towards the end it says therefore the answer should be the list of the models from the highest number, and it gives some examples. Ideally, if it works fine, it gives you top 10 models. I don't know why it's not working right now. Sorry, demagogues. But all of this code is on my GitHub. It's called Experiments with MCP. You can find it, and we can see. That's just a quick way to show what these models are capable of. Typically in companies and so on, you would be using OpenAI compatible models or OpenAI models, Claude, from Anthropic and so on. But you can do a lot of these just with open models, which are probably a fraction of cost, and for local workflows just work directly on your laptop. Cool. So what do you use these models for? These local models, first of all, you should use them for really small atomic operations, which means let's say you want to rewrite, let's say you want to translate, let's say you want to convert unstructured text to structured text. Use local models for it. You really don't want to use really large models for it. If you want to use web GPU, now everyone has access to sort of good machinery, and so if you want to do I don't know, background removal, you want to do I don't know, run LLMs on your website and so on. For that, web GPU stuff less than 4 gigabytes, browsers can work quite well. For offline use, this is a very important use for sort of governmental use cases, wherein you have air-gapped laptops, servers, and so on, and you don't have the luxury of having OpenAI calls or Anthropic calls and so on. So for those, it works quite well. For tinkering, testing workflows, it's quite well. It works quite well just to get an intuition of how things work, and for a bit of profit. Cool. Now, couple of facts just to show how the landscape of on-device machine learning is from Hugging Face standpoint. As of today, every month we service roughly 5 to 6 billion pulls of these large language models or machine learning models from the Hugging Face hub. There are close to 230,000 large language models alone on the Hugging Face hub, which people are using. And these are just public. I don't have info to private. There are 120,000 sort of llama.cpp, llama specific models that you can use. On any given day, we service roughly about 7 petabytes of bandwidth per day. Thank you, AWS. Yeah, so now that we know that these models are used, we know what we can use these models for. How does one prepare these models? First of all, you pick your desired LLM. It could be a fine-tuned LLM. It could be a pre-trained LLM. It could be your Llama, Quen, I don't know, DeepSeek. Pick your favorite. Then you check if it's supported in transformers, which is a library, again, also by Hugging Face. If it is supported in transformers, then check if it's supported in llama.cpp, MLX, Onyx, blah, 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 and convert. Once converted, assuming it converted properly, vibe check if the output of the converted model and the original model match. If that matches, double check if the chat template works. If that works, then profit. And this is all like a really involved step. Sometimes it takes days, sometimes it takes weeks, and so on. And this is like typically me, like, explaining to a research group or like one of our clients is like, this is how you make like a model run with like llama.cpp, llama, pick your favorite poison, like VLLM, and so on. Sounds simple. What could go wrong? Well, really, what could go wrong, right? Well, you could have like wrong tokenizers. This typically happens when you have a new model. Tokenizers are the one which convert like, because your LLMs just understand numbers. They don't understand text. So tokenizers are what like maps text to like these numbers. You could have just the wrong mapping. There is like more on like transformers level, like you could have like issues with rope. You could have like chat templates. Everything goes wrong when it comes to chat templates. These models could be multimodal, which means that they take audio in, they take image in, they take text in, and so on. And maybe your laptop doesn't support it, whatever. It could be a new architecture like DeepSeek or like Qwen and so on. That could go wrong. Yeah, here's some of my colleagues fixes to llama.cpp. This is when like Llama 3 was released. Thank you, Zuck. And there was an issue with tokenizer. And this was actually like, fun fact about this is like as soon as Llama 3 was released, essentially exactly at that point, Pedro, my colleague, shout out to my man, he opened a PR to fix the tokenizer for llama.cpp, and you can see from the reactions that people were like, "Thank you, Pedro." Then when DeepSeek released DeepSeek v3, as soon as it was released, like the community got behind it, and like there was this PR because DeepSeek was a mixtures of expert model. You don't need to know what MOE is, but essentially it is different than normal LLMs. When there were Qwen-based like distilled models, there were different tokenizers and so on. Also, shout out to Georgie, who created llama.cpp. If you're listening to this, great job, man. Cool. So how does Hugging Face contribute to all of this? Well, we have the Hugging Face Hub, where we have millions of these models, and you can pull these models for free. Thank you, AWS, again. We have like a core set of libraries. So there's transformers, there's tokenizers, safetensors, Hugging Face Hub, lots of stuff that goes, like lots of stuff uses it like internally. Safetensors is like the safest way to like, have your models. We have specialized libraries for running stuff on Onyx, Neuron, TRTLM, lots of that. We have a plethora of on-device libraries. We have Candle, written in Rust, transformers.js for JavaScript, also a bunch of like CUDA-based stuff. We have converter spaces. So the whole process that I listed here, you can now just go to like a space on Hugging Face Hub and just like convert models without having to worry about all of this. We're also core contributors to pretty much all libraries that exist and have anything to do with LLMs, which is llama.cpp, VLM, TGI, SGLang, and so on. Love all of them too. Cool. So you might be interested in like how these models are progressing on the hub. Like it's sort of like good to understand like how the adoption is, right? So more number of models created means more adoption of these models, right? So just like llama.cpp or like ollama cons in this case, like you can see that there's like a quite nice and steady sort of increasing trend. Like that's essentially number of models created monthly just from one space. Like actual models are much more than this. And you can see that it's kind of like increasing quite nicely. If you look at MLX, it's going through what I call like a pretty much like a hockey stick growth. Like MLX again is like a way to run like models directly on your Apple devices from the Apple team. It works quite nicely. Quite bullish on them. So on. Last slide. What am I most excited about next? So I'm quite excited about llama.cpp, like essentially having streaming tool calling support, multi-model support. I'm excited about transformers having a backend in TGI, VLM, and SGLang, which means that you just use one definition of these models, and like you can run it across different runners. I have been like I have spent like significant amount of time in the past 2 weeks on model context protocol, and I think like it's like the way to sort of like augment your model with different tools, search, just access to like a VM, have them run code and so on. Then more accurate sort of quantization schemes than we have right now, and of course like leaner and easier packaging. That was a lot. Thank you very much for listening in, and happy to take any questions if you have time.
Okay. Thank you. Great talk. So we have a few questions on Slido. Let's try to answer them all. Probably we won't. So first question is, given your extensive experience with local models, what is like your preferred trade-off between quantization and model size? So like, would you prefer a 14 billion parameter model at 4 bits or an 8 billion parameter model at 8
That's
bits?
a question which I get all the time. So typically what I would do is I would look at how much VRAM I have. So let's say like I have 30 or 32 gigabytes of RAM. Then I would try to find the biggest model I can fit in 32 gigabytes, right? And then like try to go like down the quantization layer. So like there's Q8, Q6, Q4. Do not go below Q4 unless like, someone forces you to. Anything above Q4 and, the largest you can fit, choose that. Hopefully that answers the question. Otherwise, find me answer.
Okay, then we have, are tiny agents intending to be used locally, or can they be served for model remotely?
Yes, so tiny agents actually was built for like remote only. It's only because we are quite passionate about on-device models, so we added like the support to do like on-device. But you can use it with like all like remote models, OpenAI, Claude, whatever it may be. The code is actually like really, really lean. Like it's like less than 100 lines of code. And the idea behind it is to just like give people a space to tinker around. You can also use it in like production and so on as well. It's very simple, but yeah, both supported.
Okay, great. Then let's go with this one. You should access to the browser. How can you make it like safe to access the browser with a model?
Well, yeah. So essentially, like we use Playwright. So there are multiple ways to it. So we use like Playwright, in which case like you give it access to the browser. But typically, like in a production setup, what you would do is you would have VMs, right? So you would spin up VMs on the fly. You would give the access of the VM to your model. Like E2B is a very good example of that. And like you have the model essentially mess up in that VM and not on your laptop. But I like to play live on the edge, so I just gave it access. But typically you would just use a VM and spin it up. They are cheap. Use them.
Okay. A couple more. So what's your machine specification? Does llama 30 billion parameter require strong equipment?
Okay, yeah, I should have bought my other laptop. But this one is like a fully spec'd out M4 Pro, M4 Max, whatever. But you can, like my other laptop is like a 24 gig. Like you can actually use like very small models as well. Like you can use like 2B, sort of 3B, or like 6B parameter model on a very simple MacBook Air. Like the cheapest MacBook Air would also work. Or just like get like your own like sort of CUDA device and so on. But like there's really like no issues with using smaller models. Like you can use any, like you should be able to use, for example, tiny agents with like a llama 1B as well quite easily. Hope that answers the question.
Okay, then more philosophical question. Do you think open source models serve as an alternative to proprietary models, or are they more of a competitor?
100%. I feel like I'm a big proponent of open source models. If I cannot see the if I cannot see like the tensors, then there's really no point of using it for your production workflows. We've seen like time and again that be it like OpenAI, be it Anthropic, they keep on changing the model in production. Like one day it would be working, the other day, like the same prompt would not be working. I like having as much control as possible, especially if I'm putting these models in production for like my clients, my customers, and so on. So I think like the initial cost of onboarding open source models or open weights models is a bit high, but it's so much more worth it to use those if not. And as also Simo Wilson, Django guy, also says that if there is an open weights model, then you can build stuff on it, and even like 10 years down the line, you would be able to recreate it because you have the actual weights of the models, right? So use open source models. If you need help, reach out to me. Yeah.
Okay, great way to end the talk. We don't have time anymore, so we need to finish this now. Thank you very much for
Thank you.
this.